Okay, so this morning we're just going to correct the assignment from yesterday quickly, and then I'm just going to give you one more really tiny assignment today. We're just going to wrap this unit up, and then tomorrow we're going to start on the circle unit. And strangely enough, the circle unit is all about right angle triangles. Okay, so these first few questions ask about the line of symmetry, so where we can cut a shape in half and it has two exact pieces, and they are like a mirror reflection of each other. So we have this right angle isosceles triangle, and we can only cut it in one place, be right here, and you could flip that over, fold it, and it would be exactly the same. It would fold onto itself. That's another way they describe that. So line of symmetry, just one. Okay, how many lines of symmetry are in a parallelogram? And parallelograms are kind of weird. Okay, it doesn't matter where we try to cut this thing, we could never fold it on top of itself. Even if we cut it here, when we fold this down, the point's going to be there, so it's never going to be a mirror reflection. So the actual answer there is 0. Okay, moving on. Okay, now the key word here is regular polygon, and yesterday we talked about what regular meant, and regular means all sides are exactly the same. Okay, so how many lines of symmetry are there? We built a little chart, and however many sides there are, that's going to be the exact number of symmetry. So the polygon, we're going to count sides: 1, 2, 3, 4, 5, 6, 7, 8. Therefore, that means that we would have 8 lines of symmetry. Okay, and if we started doing them, we know we can cut it right in half. 1, 2, 3, 4, right? But then we can cut it in half. 5, 6, 7, and then 8. And even with my freehand and only 2 cups of coffee, you can kind of see that we have exactly the same slices of pizza here, right? So 8 is the answer there. Okay, how many lines of symmetry are there in the letter below? And some letters do have lines of symmetry, but there's nowhere that we could cut this R in half where it would reflect upon itself. So the actual answer is 0. And then I don't know what happened with my printer here. It says, how many lines of symmetry are there in the letter below? Well, I don't know what they're talking about here, because that is not a letter. It is simply a rectangle that's half shaded. So there are some lines of symmetry. We could cut it across, or actually it won't work here. I see what they're saying here. Okay, if we reflect it, it's not going to be exactly the same. This is colored down here. Okay, so the actual answer here, if we cut it like this though, we could fold it this way and we would get a perfect reflection. So this is kind of a weird question because it's asking for the letter and then there wasn't a letter there. So if you wrote that there were 2 lines of symmetry in here, I could understand that, but literally there's only 1 because we can flip it that way. Okay, so kind of a weird question. If we were in class, I would have said don't do that. Don't bother doing that one. It's weird. Okay, now we're going to move on and we're going to give the order of rotational symmetry. So what I did here was I actually took a piece of parchment paper and I did that. I'm going to see if we can rotate it so it's on itself, right? So here we go. If I rotated it, and as I'm rotating it, you can see that there's no place where it's actually folding onto itself. So as I keep going and I keep going and I keep going, I'm going to have to do a full 360-degree rotation before it comes back on itself, right? So is there rotational symmetry? No. Okay, there is no rotational symmetry. Okay, so an order of 1, remember, is not good enough. There's no rotational symmetry there. Okay, so it went all 360 degrees. So rotational symmetry of 1. Okay, give the order of rotational symmetry of the kite. And I did also make a cutout of the kite so we could see this. I'm not doing very well one-handed here. So as we rotate it around the axis, you can see that there is no place, even when we get to 180 degrees, a kite is kind of weird, right? It's not going to fold onto itself. You think that it might at first, but it doesn't because these sides are shorter. So we'd have to go all the way around. So we had to go a full 360 degrees before it came back to its original position. So rotational order of symmetry 1, okay? Which means it has no rotational symmetry. Okay, now again, looking for that keyword. Okay, we've got a regular polygon. That means all sides are the same. So as I turn this, okay, and what we should do is we should put a little dot at the top so we know, because they're all the same, so you could get confused. Okay, so here's one time that it folded on itself, 2 times that it folded on itself, 3 times that it folded on itself, 4 times that it folded on itself. Okay, with my crappy drawing though, 5 and 6 times. Okay, and so you didn't really even need to cut that out as soon as it said that it's a regular polygon. And we take a look at how many sides it has. 1, 2, 3, 4, 5, 6. Okay, which makes it a hexagon. Therefore, we should have known that there's a order of rotational symmetry of 6. Okay. Last 2 questions. Okay, and these are kind of weird. You should be able to see that the letter F is not going to rotate on itself. Okay, if I put the letter F there, I'm going to have to make a full 360-degree rotation before it looks like it's the letter F again sitting on top of itself. Okay, so what's the order of rotational symmetry? The order is 1, which means it has no rotational symmetry, right? Because you have to have higher than 1. Okay, and the same thing's going to happen here. There's no rotational symmetry. Okay, so we would say that it has an order of 1, which is no rotational symmetry. Okay, quick 2 little questions from the textbook. I'll put a picture of them up. I also have a classwork assignment today, and that is mainly just because I need to see how to work the Google Classroom. So if you could participate in that, that would be fantastic. I also need to know who is showing up. I have to put in a list. So if you could just do that, remember the marks don't matter.